Okay, thanks everyone for joining. Today is the 4th of February. It's our February 2021 meetup, typo there, with Hermez Network as our guest. And before we start, for those of you who just joining the first time, typically we do an announcement and monthly roundup of what happened in Ethereum. And then we'll have a sharing by a local dev. And then Jordi will share a little bit about Hermez, and we'll have a fireside chat where myself and everyone else can also ask him questions. So some announcements. We have next Monday, Access Malaysia is going to do evening with the DEXs or exchanges. They're going to host Luno, Tokenize, and Synergy, all three of the regulated exchanges in Malaysia. And feel free to join if you want to hear about their thoughts on the space. Sorry, I got a comment that my line isn't very clear. Give me a second. I'm just going to change my Wi-Fi connection quick. Okay. If you guys get any kind of like line breaking, let me know. I'll make sure to change the connection. And yeah, so I can follow up on the second part later in the Telegram group. If there's any interest for a joint meetup with other meetup groups, I'm looking at Ethereum Taipei because they share the same time zone as us. And it might be a little bit more of a chilled out meetup where it's not like a proper presentation and panel, but just for us to meet their community and for them to meet our community. So let me know if you guys are interested in that. And some roundup stuff. We have the first main thing is the year in Ethereum 2020. So this is done by Josh Stark and Evan Van Ness. I'll share the links later, but if you guys want to like have a bird's eye view of what's happened in Ethereum over the last 1 year, that we always annually the best article to read. We also have Reddit, who's just announced a formal partnership with the Ethereum Foundation. For those of you who kind of kept up with the news last year, they worked with the EF to work on a scaling bake-off of how to scale Ethereum so that Reddit can implement their community points, which are tokens for some of their subreddits. And interestingly, kind of not related, but I'm sure everybody here already knows, there was a very popular subreddit called Wall Street Bets that made news worldwide, both within, well, mostly outside of crypto, but also within crypto. And it's kind of, a lot of people would say it's kind of highlighted the need for DeFi, for sort of financial infrastructure that we're not relying on big central parties for. Then a third one is the state of 1559. So there is an EIP 1559, which is also a very interesting topic on top of layer 2 scaling. I'm highlighting it here because last month there was a little bit of drama with some miners kind of complaining or resisting the change for the EIP. And it's a very interesting topic. I'll also share like a good YouTube video that just explains it in simple layman terms. And the key thing here is just that we can have a more predictable sort of gas market or transaction fee market, so that I'm sure people here have experienced over the last 1 year, especially how you can put in like a gas price that's already expensive and still end up not being able to execute your transaction. So this EIP would definitely help a lot with that, and also with some other benefits to the blockchain as well. Just yesterday, I think Visa announced they're doing like an API for banks to be able to buy a lot of crypto, not just Bitcoin, Ether, and especially stable coins. So that's kind of a good signal for what's going to happen in 2021. And both Cloudflare and the Brave browser announced support for IPFS. This is also a completely separate topic outside of DeFi, and also very interesting. Potentially in the future, we'll get them to speak, where it's about decentralized websites, and you can have websites that you don't have to host in a centralized server. and the fact that they're being supported by two of the biggest sort of infrastructure providers on the internet is also very good for the space. And lastly, some local news. Last month, the LHDN, or the tax authorities, announced that even though Malaysia doesn't have capital gains tax, all of us are required to pay taxes if we are actively trading cryptocurrencies. So don't ask how they'll track your trading. If you're doing it on a KYC exchange, that's already one clue. But yeah, if you're doing it for arbitrage, as some of us have mentioned in a couple of last meetups, or just to trade in and out, make sure that you will be liable for any taxes. So yeah, keep that in mind and track your transactions if you're doing that. Yeah, so that's it. Before we welcome Jordi, actually, we have a local developer, Atlas, who will be sharing a little demo about his project. So Atlas, I'm gonna share it quick, and let me see if we can find you.
Okay, can you hear me, Harry?
Yes, yes, okay. Cool. I'm gonna time you because we don't have that much time. So between 5 to 10 minutes, just a
Okay.
quick introduction to your project.
Okay.
And you can share your slides. Go.
All right. So I start now. Okay, I'm a founder of btcschools.net, and btcschool.net is practical-oriented tutorial site that work similar to WT schools. So why we come up with this idea is because we want for people to people interest can enroll to blockchain world. So we discover and share good repository because we see some of good repository in GitHub they are unknown by others. So we pick the good repository and put inside this website. Then we promote buildiness of decentralized technology. So far, this BTC school is non-profit website. We just want to collect more traffic and build community, and of course, we grow together. So that's all my introduction. So I hope you guys can share my website to others so they can benefit from this tutorial website. Thank you. Okay.
Thanks, Atlas.
Uh,
Did you share the link earlier?
I yes, I share in chat.
Okay, okay, cool.
Uh,
Yeah, and if I understand it right, it's a lot of it is for PHP developers, right? To help them
ah,
code in Ethereum.
yes, yes. Up to now is more in PHP because I'm more familiar to this technology. But I hope in future there are other people can contribute other technologies so we can build up this community better. Okay.
Okay, yeah. So if anyone's interested, reach out to Atlas later, and um, feel free to also ping some of the I can see some of our smart contract developers locally are here as well. And yeah, anything that we can help to contribute on the community side would be very useful for everyone.
Thank you.
So yeah, thanks Atlas. Okay, cool. So now please all welcome Jordi. And Jordi, we've tested your slides. Feel free to start sharing.
Thank you very much. Well, I'm Jordi Baylina. I'm the technical lead of Hermez, but among all, I'm an Ethereum developer. So I'm an engineer at the end, and a believer of decentralization and just working in trying to bring decentralization to all over the world. So here I want to present the Hermez projects. Hermez project. Let me share the screen if I'm able to. Just share. Okay, share. So there we go. So what's Hermez? Well, Hermez is a rollup. It's a layer 2 solution, mainly for sending payments over Ethereum. Right now, when you are doing a transaction with Ethereum, especially if you see the last days, it's really expensive. Yesterday, for example, I have to make a payment and I pay like $20 for a single transfer, which is something that's crazy. And why that happened? Well, that happened because decentralization is not free. Decentralization, so the quantity of transactions that can be done in Ethereum is limited. This is actually a limitation of any blockchain. Bitcoin is about 1,000 transactions every 10 minutes. Ethereum is a little bit higher. It's about 30 transactions per second or 40 transactions per second. But you cannot grow more with the technology that we have right now. With the layer 2 solutions, so many things has been proposed in the last years in order to scale. Here we can see payment channels, we can see side chains, plasmas. So there is different approaches and different solutions. But recently, we saw that there is conceptually a very simple idea. That's the rollups that actually can scale and can give much more, 1 or 2 orders of magnitude more transactions at least. So Hermez, it's about that. It's about increasing the capacity of Ethereum. It's about increasing the capacity of the number of transactions that can be done in Ethereum. So that means that suppose if you increase the offer, then the price of the transactions should be low. But of course, if there is a lot of people that's also using, maybe not. But that's why it's important to scale, to do as much transactions as we can, so that everybody can use it, the transactions. The promises here is if Ethereum at full capacity is 32 transactions, with Hermez Network, the full capacity would be around 2,000 transactions per second. This is, as you see, is 2 orders of magnitude more. And this is just the beginning. This is just the first version. This can increase a lot. So what's the idea behind a rollup? How a rollup works? Well, a rollup is like you can see it like a side chain. If you imagine it's a normal blockchain. What's a blockchain? At the end of blockchain is a database of balances. Okay, you have transactions and you are processing those transactions. So you create a new state with the new balances. So when you are transferring from one address to another, you are subtracting from one addresses and adding to an address. So when you have a balance, this balance can be hashed, can be with a Merkle root, can be compressed, but can be hashed with just a 32 bytes number. It's just a very small number that represents the full state. So you process all these transactions and then you create a new state with many of these balances modified because you are transferring things. Okay, so you are increasing. So you have a state root, then you have another state root, another state root. So the way to increasing these balances is through a smart contract, is through a transaction. So mainly what you are doing is you are sending all the transactions to a smart contract, and the smart contract creates a new balance. Okay, and then you can have like a blockchain inside the blockchain. Okay, that's the idea of the rollup. But why the rollup scales? Why can we make much more transactions? Well, there are two kinds of rollups. It's like the optimistic rollups of ZK-Rollups. But the idea is that so if you just put the transactions on the smart contract, the problem is that the smart contract needs to verify that those transactions are valid. What means that those transactions are valid? Well, for example, that the transactions are well signed, or for example, that you are not sending more money than the one you have. Okay, so you need to verify that. If you have a smart contract that needs to verify all those transactions, this would be very, 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 very expensive. So how can we reduce this verification? How can we make a smart contract that the verification, the cost of verifying all these transactions is very small? Well, actually there is two techniques, is the optimistic rollup and the ZK-Rollup. Optimistic rollup, mainly what it means is, okay, you just put the new state and assume that's valid. And if somebody sees that's not valid, then you can challenge, and then the people challenge, and then actually the coordinator, the one that published these new transactions, and needs to send a proof that actually this transaction is valid, and so on. And there is this gaming on the optimistic rollup. In the other side, zk-Rollups, what we are doing is we are using a new technology that's now called ZK-Snarks. And actually, ZK means zero knowledge, succinct, non-interactive. So it's a succinct, non-interactive. But the important part is this succinct. So actually, what are we doing? Well, we have a primitive, a cryptographic primitive, that actually what you can do is you can execute a program. In this case, for example, is verifying all those transactions, which is a very expensive, a cost computing, very expensive computation. You can execute a program, but instead, so the idea is that so the coordinator can execute the program, can check that everything is good, calculates the new state, that's assuming that's valid, and then you just send a proof, which is it's a cryptographic proof that the computation is done in the right way. And the cool thing of this technology is that this proof can be verified on chain and very cheap. So we can compress, all this huge computation, maybe just taking 2,000 transactions and verifying in all the everywhere that that it's valid, that the signatures are valid, and everything that's very expensive. You had to do it with gas. It would cost trillions of dollars, trillions of gas. It would be very expensive. We can put all this calculation and just create a proof and say, okay, this is the initial state, this is the exit state, this is the transactions that we are processing, and with this proof, I guarantee that this state is valid. It's computed in the right way, is done in the right way, the transactions are valid. Okay, and the verification, that's actually what's done in the consensus, is it's done in the blockchain, in the smart contract. This is very cheap. It costs like 200,000 gas. It's constant, and it's constant time. It's constant time. It's constant gas. It costs that thing. And this is what allows us to put a lot of transactions in Ethereum, and just put this proof, and then we escape. Okay, so here we have, in general, the rollups consist in dividing the problem in two problems. One is this computation problem that we solve with ZK-Snarks. Actually, we put 2,000 transactions, but we could put more. We can put millions of transactions, and the cost would be exactly the same. But there is another limitation, is that we also need to put the transactions on chain. We need to send the transactions. We need to put this data. Okay, the data. Why we need to put this data? Because if there is an operator that just processes transactions and puts a new state, then this state, okay, you have a number there, but you don't know where it comes from. You don't know what transactions are there. So the operator could just block, could say, okay, this is new state, but I don't publish this transaction, so nobody knows how this state was calculated. So it's important that this data is available. It's important that this data that the people can see this data. So one way to do it is put this data on chain. That's actually what a rollup do. There are other techniques, and here is where we have validiums, for example, that they take this data and put it in a federated servers, or put it in something like IPFS or whatever other mechanism. There are other alternatives. For example, you will be able to put this data in Ethereum 2, in the shards of Ethereum 2, which is great, because Ethereum 2, the promise is that you can put a lot of data very cheap there, so you can put this data there. So there is different mechanisms, but you need to guarantee what we call it the data availability. Okay, and this is Ethereum 2.0, especially the step 1, the sharding, when you can put this data. This will solve that. That's why it's so important that for scaling Ethereum 2, because we have this data availability. And actually, you see the Ethereum 2.0 roadmap. That this data availability with the rollups, this is what will make actually to scale a lot Ethereum. Okay, so well, we talk a little bit about this data availability. Okay, and yeah, that's mainly how a rollup works. Okay, so you have different transactions, you are just processing and you are advancing. But who forges those transactions? Who forges those batches, those blocks? Who make those transactions? Well, this is we call the coordinator. But here we have some point of centralization there. So if I'm the coordinator and then I can, for example, censorship somebody, okay, or I can decide who I forge, who I do not forge. I can do a lot of things. Okay, so this is a certain point of centralization. So how we solve in Hermez? Well, in Hermez, mainly what we do is that anybody can be a coordinator. And how we do that? Well, mainly what we do is we divide the time in 10 minutes a slot, actually in 40 blocks a slot. It's about 10 minutes. And there is an auction, so anybody can bid for one of those slots. If you are the winner of this bidding, then you will be able to forge as many transactions, as many batches of transactions as you want or as you can in that 10 minutes slots. And of course, all the fees of those transactions will go to you. So coordinators will have to see, okay, what's my operating cost? How much transactions do I think that I'm gonna put inside? How much fee do you think that I'm gonna get? And then I do a bidding. I do a bidding on that. Okay, so here is a way of selecting what's the best coordinator. Okay, so this is a kind of a bidding on how the system works. There is some other details. For example, if there is nobody bidding, then we will run a bootstrap coordinator. But the idea of Hermez is we will start a little bit centralized, and the idea is to decentralize as fast as we can. So the idea is to build censorship resistance, decentralized layer 2 solutions, so that we don't, at some point, we should not have any control at all over the network. And I hope that this could be as soon as possible. Okay. So this is the idea. There are some attacks. For example, somebody at the beginning may buy all the blocks and things like that, and then we have some specific mechanism. I don't want to go deep on there, but we have some different mechanism about protecting that. So here we have different, for example, here we have different types of slots, and the idea is that we can maybe we can decentralize the even slots, and the odd slots maybe it's more expensive, and we have some techniques for the bootstrapping for the beginning, so that the network can run smoothly at the beginning, where it's more dangerous, where the decentralized systems are more dangerous in general. Okay. Of course, here is what happened. But even that, there is a mechanism. So imagine that all the operators that are there just censor somebody, or censor, for example, some token. Says I don't want to. Or imagine that it censors you. Well, what happened with the people that has money there? Well, they can do, for example, they can force an exit, and this is done with a layer 1 transaction. So they can do a transaction, and then in the next forge, so in the next time that the forge is mined, the transactions needs to be included. If not, the block will not be valid. Okay, so with this guarantee that there is no censorship. Well, maybe there is censorship because you will not be able to use this rollup, but you will not lose the Ether. You will always be able to get the money, get the tokens, and maybe use another rollup or the layer 1. So we have this mechanism of censorship resistance. And of course, if there is no operators, then we have a timeout, and then you can yourself forge a block in that case. Okay. We also include atomic swaps. Atomic swaps are a transaction that you need to, the transaction that's only valid if another transaction is also included there. So this is very interesting for for decentralized exchanges to be built on top of Hermez. That's something that's in the protocol. Okay. We have also, I don't have a slide for that, but we also have a massive migration system so that we can cheaply transfer from one from one smart contract, from one rollup to another rollup or things like that. Okay, so that's mainly it. We are in Hermez. We were working before mainly in the Hermez. We are the identity team mainly. We were working a lot in the ZK Snarks tool, and mainly what we are doing is we are taking these tools that we made by identity mainly, but we are building this rollup that we believe that's important for Ethereum. I don't know who I in time, but for me that's the presentation that I prepared.
Okay, cool. Thanks, Jordi. A very succinct presentation. So next we'll do just a fireside chat, just so we can ask Jordi a little bit more questions about not just Hermez, but like ZK-Rollups and scaling in general. If you guys have any questions, feel free to put it in the chat and I'll make sure to ask. Or you can wait until like after I've finished asking Jordi my questions, then you can unmute and ask yours. So up to you. But yeah, so I have a bunch of questions prepared, all around rollups and Hermez. And the first thing to ask actually is for the people here who may not be very clear on what's the difference between the scaling methods. Would you be able to share at first the difference between ETH2 and layer 2 scaling?
ETH2 is an evolution of the layer 1, I would say. It's a proof of stake, there is a consensus, a different consensus mechanism that includes sharding. Actually, it's the same that we have in Ethereum 1, but just making more scaling from the basic layer. But this is quite difficult. Okay, so this is the evolution of Ethereum. Ethereum has its roadmap. We started with this beacon chain. Now, with next step is just putting this sharding and start have all the migrations. There is different phases. You can check any of the Ethereum 2.0 scalings. But rollups is something that we have it right now. It's something that can be run even in Ethereum 1.0. Actually, Ethereum is going to run in Ethereum 1, in the current Ethereum. So it's something that's still there. But they are absolutely complementary things. As I explained before, rollups solve the problem of the validation of the transactions, of scaling the validation, of scaling the processing part. The idea is that there is one person. It's with a big computer that computes, that do these validations and generates this proof, and then in the consensus layer, so all the nodes in the network, they just validate that very cheaply. Okay, so this is solved with the rollup technique. But the other thing, and this is important in Ethereum 2.0, is the data availability. So at the end, it's like it's a world storage, a world hard disk where you can put data there, and you guarantee that this data is gonna be there forever and nobody can delete and check, but with huge amounts. Right now, a normal blockchain does it. You put a blockchain in Bitcoin, for example, and this data is gonna be there. But you are gonna put some bytes. In Ethereum, I read the other day that they are planning to do they want to put 1.5 megabytes per second, which is huge. It's like, you just do the numbers, but that's a lot of data, and all this data is going to be available. So with this data and with the rollups, then is when you can scale. With rollups, we start with payments, but actually you can build rollups that you can execute a smart contract, so you can do everything. So instead of a payment transaction, you can do a smart contract transaction, and this can scale. There is a lot of research that's done in that way. There is new primitives to optimize and to do things better that are currently in research phase or in deployment phase, but it goes together. And the interesting thing is that the strategy of Ethereum 2.0 roadmap is to join both both ideas, data availability with learnings of the rollups. Actually, at the end, they are mixing what was the old before. You know, in all papers is you see the execution environment. This is a very similar concept that a rollup, and actually currently it's like they mix one thing. So a rollup is a kind of execution environment, but so like it works that way. So we'll see. But Ethereum at the end is going to be a rollup or a set of rollups with a data availability that will work together.
And then the natural question, well, one of the natural questions after that would be, what's the difference between ZK-Rollup and other L2 solutions? Or maybe just focus on ZK versus optimistic rollup.
Yeah, I explained it a little bit before, but the idea is that with ZK-Rollup, you just, once the operator puts the transactions there, you have finality. You know that this transaction is valid cryptographically. It's there. You don't. It's expensive to generate those transactions because you need to generate these proofs, and these proofs you need a lot of computation. But once the transaction is there, it's there. It's done. Okay. With optimistic rollup, it's not the case. So the optimistic rollup is I'm optimistic. I just put the block, the forge, the batch in the transaction. I just make the transaction. I say, okay, this is the next state. The next state. But the network actually accepts a wrong. Maybe there is one of those transactions that do not have a valid signature, and the people continue working on there. Okay, so optimistic rollups requires this gaming mechanism. Is that okay? If somebody sees something that's not valid, then you can challenge, and then if you challenge, maybe you earn some money, and then the operator can change a proof that actually is valid, and if he doesn't send a proof, then they lose money. So they're doing this kind of gaming of gaming. So one of the consequences of that is that, for example, the withdrawals in optimistic rollups, there is a delay. You cannot withdraw the tokens in the moment. With ZK-Rollups, you can do it once the transaction is there, so you know that the transaction is smooth, so you can withdraw it very fast. The finality is very fast. But in optimistic, you need to wait more. Okay, but the other side, optimistic rollups, you don't need to calculate the proof.
And one thing that's been mentioned between the two is how, well, in DeFi especially, there's this term composability, and how, and please feel free to correct me if I'm wrong, but what people have said is that optimistic rollup allows you to be composable, whereas ZK rollup, at least at this point, doesn't provide that capability.
Yeah,
actually, can you also introduce composability for people who might not be?
Well, at the end is executing smart contracts. So the meaning is that executing smart contracts, and actually with ZK rollups, it's like it's very easy to put a fixed program. For example, just for transferring tokens. But even you could add, for example, a Uniswap kind in there. So you can do whatever you want in there, but you have like a fixed thing. Okay. So if you want to run the smart contract, so you can have possibility and whatever you want in there, then you need to do some variable logic in there. So you need to put a program there. Okay. And this is more difficult. Actually, it's doable. The new techniques in ZK-Rollup, if you see, for example, Plonk, Lookup-Plonk, Halo2, all these new cryptographic primitives that allows to do that. They are very new. They were like discovered like last year. So people is still learning how it works. Okay, but it's there. They're already there, and we will see those primitives to become a reality in the upcoming years. So composability and any kind of, you will be able to run any smart contract on top of a rollup. This is absolutely doable. It's just a matter of time. It's just learning more, doing tooling and searching and putting there. But it's actually possible. Okay. With optimistic rollups, the cool thing of optimistic is that's easier, okay, because you don't need to generate this proof. So actually, this challenge can be done off chain, and then you can put a program, or you can put more easy anything you want in there. So optimistic rollup, I would say that they have this advantage that you don't need to build this proof, okay? So because you are not building this proof, you can do more things. But then you have these other disadvantages of delay and all this game theory that's behind is not easy to understand. It's personally, well, I'm a little bit biased, and I'm a little skeptical with optimistic rollups. So that's the truth. But they are there. There is people that there's a lot of interesting projects that are trying that and are putting that. They're going to mainnet. So we'll see. But it's a kind of a strange competition, because I don't think it's a competition. It's just two technologies that are there, and well, we'll see some of each one with each advantages. But and we will see what are the ones that end up succeeding and which not. But it's new technology, it's new things. It's something that we didn't 2 years ago or 3 years ago. Nobody knew about these rollups and all these scaling solutions. So this is very new.
Yeah. So I think it's even been described as moon math, the zero knowledge.
It's, I would say, I don't think it's that hard, this math. The problem a lot of times is that if you read directly the papers and academics, is they have very complex
Terms and
they have a way to write, and it's very difficult to access to this to actually understand. It looks like moon math. It looks like something like something magic in there. It's like you don't know exactly what's doing there. But when you more or less understand what it is, and you go deep and you see it in the right way, they are, at least to understand what's behind, is not that complex. It's I would say that a regular engineer with not a very high degree of math can at least understand what's behind, if they have the right documentation, if they have the right book, or if the right teacher or the right way to access that. If you go directly to if it's the first time that you're reading one of these white papers, research white papers, then it's like, oh, that's not for me. Yeah, just forget. But it's like, for example, I recommend people, for example, Vitalik has a very, very good blog post about all this technology and they're explained it in a very, I would say, in a very, it's explained for people with high school math. It's very, I tell you, they are not easy. You need to read them like 3-4 times and go deep, but you can, it's accessible. It's a lot of things, but it's doable. It's not that complex.
Would you, and I don't want to put you on the spot here because I understand it's not that simple of a subject, but would you be able to do like a ELI 5, like explain like I'm 5 of zero knowledge for us here?
Yeah, I explained it before. It's like, imagine that you have a normal program, a computer program. For example, imagine a function that do the square root of a number. You have x and you have to do the square root of a number, and it's y. Okay, so it should be a deterministic program. So a program that you have been given an input, you do some calculus, and you get the output. And if you put the same input, you get the same output. Okay, and this program can be very, very, very complex. Can be a hash function. Can be a lot of hash functions. It can be in the case of Rollup, it's verifying 2,000 transactions that are okay and that matches the state. So it can be a very complex program, but as you put inputs, you get you put outputs. Okay, so the idea of a snark of a zero knowledge of a zero knowledge proof or ZK snark proof is that imagine a hash function. So you have an input and the output is a hash or the square root. Let's put a square root. You have an input and you have the square root. Okay. So the idea is I can prove to you. So I can do the computation. Say for example, I can do a square root, which is hard. You know, I need to imagine that you are doing by hand. It's very hard process to do the square root or the whatever. Okay, and I give it to you. And I tell you the result is this, okay? But how do you know that this is true? You need to one way to do it is, okay, you do the square root again, okay? Which is well, it's hard. Maybe you can do the square, you can do the reverse. There are some functions that are reversible, and in this case it's easy, okay? But imagine that that's this process. Imagine it's a hash function. A hash function it's impossible by definition. You do the input, I give you the output of the hash function. It's, okay, this is but you see a random number. But how do you know exactly that this is a hash function, the result of a hash function? Well, here what I can do is when I calculate the prover, when the prover calculates the hash function, actually the computation can also calculate a proof, and then I send you the result. I send you the proof, and you very fast and very easy, just getting this proof, you know that this result is valid. But you don't need to go through all the square rooting or the hashing algorithm. Okay, so this is what about zero knowledge is, and we call it zero knowledge because you don't even have to reveal what's the input. You know that the result is the result of a square root or the result of a hash function. You know, it was calculated with so that the prover knows the input, knows what's the input, but you don't need to reveal that input. That's why it's zero knowledge, because you're not revealing anything about the inputs and all the calculus that you are done inside. You're just getting the result, you're getting the proof, and you know that this is valid, that this is okay, that this, you don't need to go, you don't need to check anything else. You just check the proof and the proof is valid. So that's and this technology is, as you can see, is very cool because it allows to do one person do this calculus, do this proof, and then you just send that to a blockchain. It has a lot of limitations, but everybody can verify that very fast. And these proofs can be, you know, this program can be huge, can be a lots of computations. But you compressing this computation, you are just summarizing this computation with a single proof, and you can verify that the full computation is valid with a single proof. And this is the cool thing of the zero knowledge.
Yeah, and I think before ZK-Rollups, at least within crypto, zero knowledge was discussed more about for privacy purposes, and we can clearly see from this example that it's not just privacy. Also, now you can batch a lot of things together, right?
Exactly, you are hiding. You are zero knowledge. And actually, in some ways, you are putting a lot of computation. So imagine you are doing a lot of computations in a single proof. So in some way, if this proof is very small, you verify that there is no information there. So this proof don't give you any information about the calculus. It doesn't give you any information about the inputs. Okay, that's why it's zero knowledge. So it goes together. If the proof is succeed, in some way, it also has this property of zero knowledge. Okay, so that's the cool thing. When you get the succeed, you get like the zero knowledge for free. And the zero knowledge by itself has a lot, as you say, it has a lot of other applications for the privacy world that are very interesting. You can prove that, for example, you are close, so for example that you are in a specific city without specifying exactly where you are, or that you are very close to somebody, or you can prove that in the case of Zcash, you are, for example, proving that you have the right to spend some money, but you don't know, you are not saying which one. Actually, you are proving that you have the right to spend some money and that money has not spent before. So that's what a proof in Zcash is. It's like or in Tornado Cash, for example. That's this privacy in the transactions. But an identity you can prove. It's interesting because you can select, for example, select part of the data and do kind of a view. For example, you can prove that you are 18 years, more than 18 years old, but without revealing what's your birth date. Or you can reveal that you have a valid KYC passed in some country, but without revealing the country or the agency that made that. You can do, or in a voting system. You can prove that you are in a census list, that you can vote, and that you didn't vote before, but you are not revealing who you are. So you get an anonymous voting. So you have a lot of applications with this same technology, this zero knowledge technology.
Yeah, and especially I guess for people in the Catalonia region, there's a lot of meaning behind having this kind of zero knowledge capabilities as well, I imagine.
Yeah, well, in Catalonia, we at some point we tried to organize a referendum that was censored by the Spanish state. So there is a lot of interest of being able to vote, and there is a lot of projects in Catalonia that in some way they were born in the October the 1st. Was this when Catalonia tried to do the independence referendum, and yeah, because people realized that was important. Also, when there is a lot of people that's in prison and it's persecuted by the Spanish authorities, they are just monitoring the internet, monitoring all the communications. They just change the law so they can do it whenever they want. When you have a state that's working that way, there is a lot of interest because there is a need, there is a necessity for this privacy, and it's I would say it's a quite legitimate privacy. With Catalan people, they are not terrorists. They don't want to kill anybody. They don't want even to hurt anybody. They are not violent. They just want to decide by themselves and be a country like many others in the world. That's the only thing. But that's why in Catalonia there is a lot of interest in privacy and voting systems and in these technologies. Yeah, but I'm sure that many places around the world they have also these needs and these requirements and this sensibility about these topics.
Yeah, it's really cool. I think in Malaysia we don't necessarily have that much of a need for these things. So it's cool to hear about what other.
You're lucky. You're lucky here.
Yeah. Anyway, I'm not gonna get into local politics. Back to the sort of layer 2 stuff. One very interesting question that has been asked is there's a difference between layer 2 and side chains. Are you able to like share a little bit more about that and what does it mean to have a layer 2 that's like native to the blockchain versus a side chain that has its own consensus?
Yeah, exactly. The difference is this one, is that a side chain has their own consensus system. For example, if you see XI, at the end is a proof of authority. It's a consensus mechanism to create a chain. And then there is just a bridge between the two chains. This bridge, in most of the cases, is it's a federated system. It's a system where you have like a multi-sig, and if you have a 3 out of 5, or I don't know, 10 out of 21, they sign one transaction, then they block it in one side and move it move the asset to the other side and the other way around. This is in general what we understand with a side chain or a packet chain, if you want. A layer 2 solution in a rollup, of course, has this concept of their own chain of blocks. So it's like they have their own state and you are moving from one, but there is no consensus mechanism. The people that's participating in the layer 2, they don't need to agree in anything for the consensus we are using layer 1. Okay, for deciding which is the next block, this is done in the layer one. It's not decided by the layer two. And this is the difference. You don't have to build another chain with layer two. You are just using the layer one, so the chain on the layer one for the consensus mechanism, and you are adding on top of that this technology so that you can put more transactions.
Okay, cool. Yeah, I hope that helps. I know there's at least one or two people that were very interested in that question. But we hear about a lot of these sort of scaling solutions, and sometimes they're called L2. Do you know if there's any like easy way for any kind of community member to kind of like pick out certain details to very easily tell whether something is a L2 or a sidechain?
L is from layer, okay? So layer two is, okay, it's like we say layer one, what we have right now, and we're building a layer on top of that that gives an extra functionality. In this case, the scalability. Or if you want, we are giving the throughput. So we are able to build much more transactions per second. But this is a um, convention. You know, we're calling this layer two with this kind of solutions. But if you see at the end, what we are doing is we are engineering, you know, it's that where we have layer one, and then we are putting, in this case, a smart contract with some topic here on layer two. But actually, we could put, for example, we can put functionality for giving, for example, fast finality, and this would be in top of layer two, and we can call that layer three if you want. But at the end is a convention. I better like to talk if it's a roll-up, it's a roll-up. It's an optimistic roll-up, it's optimistic roll-up. It's better to call by their name what you are doing on top of that, because if not, it's like very people is doing whatever. Oh, this is layer two. Well, yeah, but why not? It's better to explain exactly what you are doing, or if you want, what functionality are you adding, or what are you, what are you achieving, and what implication it has. It's better to understand actually what you are doing than just say this is layer two.
Okay, yeah, I think that, yeah, asking what exactly this is, I think generally helps. Even back in the ICO days, you know, if you ask a project, you know, what exactly do you do, then you kind of unravel a lot of things sometimes. Okay, to go back to Hermes itself, what would you say are, I know you mentioned some of them already, but if you can kind of like list the unique differences between Hermes and other ZK rollups?
Yeah, in Hermes is, as I told you, we want to build a decentralized censorship, full decentralized censorship resistance mechanism. We want to be a community. We want to be a community roll-up. What that means for that? For example, in Hermes, all these for all the bidding, you know, where it goes when the operators bid on that, where this Hermes goes. Well, there is part that's just burn, and it's important to be burned, because if not, you can lose kind of cycles. You know, it's like operators can just recover. So it's important to burn. There is a part that's burned. There is a part that goes to layer one systems. We need to understand that so it's a kind of a donation, probably will go through some kind of Gitcoin or some mechanism. But in any case, we will not control where this money will go, where these Hermes tokens will go. And this is important to maintain the layer one. For the people that's building layer two solutions need to understand that they are leaving thank you to the layer one. It's important that the layer one continue. It's important that the layer one evolves, in this case to Ethereum 2. But it's important that, you know, that the clients in Ethereum works okay, miners work okay. So it's important to invest in the layer one. So that's why in Hermes we put I think it's 40% of the bidding that we get goes to the layer one, and the other will be sent back kind of airdrops to people that's using the same to the users that are using the rollup. So here we have all the, in some way we have all the questions, and all of these decentralized, so we don't have any control on that. So that's the main thing that we are building. From the more technical perspective, for example, we are using our tools. This is very important also for testing our tools. Or tools, for example, there are other important projects that are already using our tools, like I don't know, Tornado Cash or the game, the Dark Forest game. There are other projects that are using the tools, but having a rollup with a huge circuit and so on. So it's important also for the tooling to secure it and to evolve on that. So that's an important thing that's interesting and goes also to the community and to help to other projects. Of course, all the software we are doing is open source, including all the tooling. So the idea is that at the end, the community continue to evolve. The final goal of Hermez is, like many people in this space, is that everybody in the world can use cryptocurrencies as their normal currencies. That's the goal. And saying cryptocurrencies, I would say any decentralized application, free voting, governance. So, but at the end is, you don't need to ask a permission to organize a vote, or you don't need to ask a permission to send money to somebody, or you don't need to ask permission if somebody sends money to you, it's yours. Nobody should be able to steal your money in any kind. So that's kind of basic principles, but that this is what these technologies will allow. We're still very early stage, but at least from the technical, even from the personal perspective, it's very exciting to be living in these times, because we are building all this new world.
I want to circle back to a couple of things you mentioned in that answer. So you mentioned building tools, and I think one of those at least is a tool called CIRCOM.
Yeah, CIRCOM is zero knowledge. It's just when we talk about this deterministic program, but actually you generate the proof. So you need you cannot use like a normal language there. You need to write this program in a specific way. So CIRCOM mainly is a tool that helps you to write programs for that. Then you can generate this proof. And the other is Snark.js that actually goes together with CIRCOM, but actually is what generates the proof and all the verification keys and all the tooling that you need, the smart contracts for verifying that. So all the tooling that you need to use this zero knowledge.
And you mentioned
and this is open.
Yeah. So you mentioned it's being used by Dark Forest and one other project at least.
Tornado Cash.
Yes, Tornado Cash. So strictly speaking, it's not just for scalability, right?
No. So you can use it. It's a ZK snark, so it's this primitive. But as I told you before, it's like you can use it for privacy solutions and you can use it for scalability solutions. In general, for scalability solutions, we are seeing huge circuits with a lot of constraints that are run in a cluster or in some heavy computer that's generating the circuit, and small circuits maybe for privacy, and in general they are running the same browser. It's for voting or for sending an anonymous payment or for proving some privacy, so some private data to somebody. So these are, in general, there are different kinds of applications, but the tooling is the same. The cryptographic primitive is the same, and you can write a small circuit or a big circuit, and CIRCOM allows you to do both.
So we can say any developer here who might be interested to do either privacy stuff or scaling stuff can explore using those tools.
Yeah, I would recommend that goes to CIRCOM or goes to Snark.js, and there is a good tutorial there. It should not take more than an hour to run the tutorial, and there is a lot of explanation in a very easy way how to understand it. You don't need moon math. It's just to write circuits. Is the tooling that's everything for you. It's just writing. It's like writing normal programs. Some specifics, but at the end is writing a normal program there. So I would. People interested, I would recommend to go there. Even if we have, for example, 9.3, this is not 9.3, but if you go You can go to we have a Telegram group there, so I'm giving support myself with Circom and Snark.js. So any app that's really interesting can go there, can go to the channel, ask questions there. There is an incredible community there that if it's not myself, anybody in the community will answer. And it's it's a new technology, but technology that's it's taking off now, and a lot of new things can be done. You can go, for example, the Dark Forest is like the first game for example, for gaming. You can play chess, or you can play chess. It's easy, but you can play poker, or you can play any random game, or you can do your own game and do it without the need of a centralized server. So it's like I can play poker with you and without having to trust anybody. How we do that? Well, using zero knowledge is one way, and you can build a game like a poker, for example, to do. But it's like I'm selling poker, but you can say Catan, or you can say whatever game that you can build on that. So gaming is a full industry that will help. That will help to use zero knowledge, especially when you want to do decentralized games.
Yeah, and I would just mention to anyone interested, like there's a lot of hype around anything zero knowledge or games or other applications. If you were to work on it, you might potentially be literally the first in the world to do something around that that theme that you're working on. So yeah, it'd be something cool to try.
That's the cool thing of this space. There is so many things to do. It's a new space. It's like when you check, it's new technology that's coming, so everything needs to be done, and just people coming here is just okay, just to stay studying for a while to see what the people is doing, and I promise you that in less than 1 year you will have 10 projects, exciting projects that nobody did it before, and that you can do it, and yeah, that's very exciting. That's a very exciting. Well, it's not like working in a bank doing exactly the same programs, especially for developers. Is another you can. It's much more open.
It's rabbit holes below rabbit holes.
Yeah, it's also, for example, this space is cool because we don't have. I would say we don't have a lot of competition yet. It's if you go to more mature markets, it's like they are killing each other just to get their space. Here it's so big that's like, okay, if somebody's doing something, you can do something else that's just in the other side, and it's a lot of space and a lot of things to do in front.
I see Dash, I don't know your name here, put in the chat box. Can you share another example of this? Can you clarify though, what example do you mean? Like what other games? Okay, so Dash says like the poker analogy. So I imagine any other example use cases? Yeah, applications?
Yeah, it's look, I will give you a
this is free
there are
consulting.
other ways to do, but it's like, imagine that I don't know, it's let me see. Well, in the case of the Dark Forest, for example, what they're doing is, okay, they have these the planets that they discover. So, and in order to discover it, you need to do this kind of proof of work. So you need to do some work in there. But so but you want to prove that you discover a planet, but you don't want to disclose. So you want to prove that you have a planet but you don't want to disclose where your planet is. Okay. So actually what they are doing is they are creating a zero knowledge proof. So they are computing, they are checking that this place is in the has a planet, but you are not revealing this position. So you can prove in a smart contract that that you are the owner of a planet, and the others knows that you have that planet, but they cannot know exactly where it is. Things like that. But it's like you are doing, for example, the case of a poker is, imagine that you get a deck and you are mixing it, but you don't want, so you want to, you give the solution, you give you give to the other side, but you want to prove that you are not adding more cards, that actually the mix is exactly, so it's the same set of cards with a different mix, but you only mix it. You don't generate new cards, you remove cards or do some tricks in there. So it's like you are doing something privately, following the rules, but and then you send the result, which should be maybe encrypted or whatever, but you know that it's following the rules, that you didn't mess up inside. So this is very useful for this kind of games.
Yeah, and I think it might be best just to like try playing because listening to someone explain it isn't the same as like actually playing.
Do the tutorial. It's like, I tell you, it's worth it. If I send the developer there, just go to the Snark.js, the README of the Snark.js, and also in the Ethereum, but especially the Snark.js, I think it's more updated there, or if you want both. You spend 1 hour. I promise you that you will not, at least for the tutorial, you will not spend more than that. But yeah, I can tell you that probably this is like a drug. Maybe you are going to realize that you can do a lot of things, and then this can change your life. But for the first is just do 1 hour, do the tutorials, just go there, just check what you can do there. And yeah, it's exciting. It's just, if you have any questions, just ask in the channel, but it's easy. So it's, and it's, you will discover a new world in there.
Yeah. Yeah, and for the non-developers, you can try playing the Dark Forest game. I'll share the link later. You can find. I think you have to apply for keys. But yeah,
it's very addictive. It's very addictive. I tell you, it's like I've been playing. I had to stop playing because it's okay. I'm not going to do anything else in my life if I continue with this playing these games. It's a very cool game. It's very nice, and but I tell you, it's very it's too addictive for me.
Yeah, I think there was a report that came out last month or December that like the XDAI sidechain got like its highest fees by far, and it was all because of people paying to the gas fees to play the Dark Forest game. So yeah, just shows.
I remember, I think what was one, it was the second version or the third version. They just broke Robson, the testnet. They ruined the testnet.
Yeah.
Broke
so that's why they had to move to XDAI, I think.
Yeah, that's crazy. That's crazy. That's interesting, and that's why also we need the scaling things. For these games are very interesting, but we want everybody to be able to play them. If not, they are very boring. So it's we want to be a lot of people playing in those games, and in order to achieve that, we need to scale. And we need to put a lot of transactions in the chain. And yeah, that's what Rollup is about.
I have one final question for myself. I do realize there's there's a couple questions already from people, and I don't want to forget asking them. So last question for me is, so you mentioned the proof of donation and the whole auction system. So how do you make it such that the amount of funds that is going to be given to L1 to be done in a sort of decentralized way where there's no like subjectivity of like, okay, I'm going to give it to Gitcoin instead of some other grant, or who do I channel these funds to and how?
We right now here we will ask we'll ask an Ethereum address. So we don't want to. So this is not our. We don't want to deal with that. I think that this is like another problem. So maybe what we probably will do is we will ask to the Ethereum Foundation or whatever to give us an Ethereum address. Probably they will give us a Gitcoin, a Gitcoin grant address, and we would just send all the money, all the funds there. But we don't want to. We just want to. For us, is we have a lot of problems ourselves. So it's our system is difficult enough. So what we need, we understand that we need to donate these funds to the layer one. I would not say even donate. I want to say invest in the layer one. We need to guarantee that goes to the layer one and does not go to, I don't know, to some random guy. Okay, But besides that, we don't want to decide anything else on there. So I know that, for example, there are other projects with DAOs and that are working in that way. I hope that at some point these funds can go to a layer 1 DAO or whatever, more decentralized system to manage these funds. But as I told you, this should be another project.
So just to be clear, the Hermes or Hez token, I guess, there's no governance use for this token.
We are trying, so what we are trying is to have as less governance as we can. So we are minimizing governance as we can. At the beginning, it's going to be a little bit of governance because we are not fully decentralized at the beginning. We can, for example, upgrade the smart contracts with some time lock, but we can do things like that. We have some escape hatches at the beginning. So we have some security mechanism that at the beginning, it's a compromise between security and decentralization there, okay? But we want to disable those mechanisms as soon as we can. And the idea is that all these fine-tunable parameters that at the beginning are going to be a little bit centralized, the idea is to remove the power of modifying them, and at some point the system should not have any anything that can be done by the governance. Okay, if at some point, for example, this Ethereum, this layer 1 address, okay, maybe it's not solved, and then we need to decide which is this address, okay, or where is this governance, and then maybe at this point, if there is no way to decentralize that, then maybe we will create a DAO project, or we'll use a DAO project about that. But this is like the last resort. So that's the last thing that we want to do. If we can do it without, if we can hard code, if we can do it without the DAO, then much better. That's the goal. So it's like minimizing the governance. We want to have a system that runs by itself, that do not depend on us, that's fully decentralized, and that works alone. That's a fully decentralized system. That's the main goal of Hermez.
I think that's interesting.
It's a long run, but it's like,
yeah. I was gonna say, I think it's interesting that you're going against the current trend, at least in DeFi, of having governance tokens. And I personally like to see that.
yeah,
okay.
It's like, for me, governance is it's problematic. I don't know. It's like, no, governance is very good for things, but if you can do it without governance, that's much better. Governance is because you don't have another option. There are things that are needs to decided by humans, okay? But transferring a token, you don't need a governance to transfer a token. Bitcoin has, I wanted to say that Bitcoin has no governance. Probably that's not true, but at least we want to be to have as less governance as we can.
Yeah. Yeah, like I said, I personally like that stance as well. And I think, especially coming from Catalonia, you probably have a better sense of the kind of possible messiness of getting humans.
Yeah, but this censorship resistance, this privacy, all these values that that are important for us, of course, or even it's the freedom itself. It's if you never had the need about freedom, if you never had the need about privacy, if you never had the need about censorship resistance, probably you would not appreciate, or at least in order to appreciate, you need to do an intellectual effort to understand that. But the people that at some point had the lack of freedom, had the lack, so that they needed the privacy, and they needed this censorship resistance. They need this decentralization. Then is when you actually you change your mind and say, okay, you see the importance of those values. So it's importance of that. Privacy, for example, is something that Yeah, that's a typical thing. It's like people do not care about privacy until they need the privacy. But actually, when they need it, because they are not never having private, then when they are using something private, it's like, okay, you want to hide something. If you are using privacy by default, if you are doing everything private by default, then you will have privacy. That's why it's important that the privacy to be by default, because if not, it's useless if you just use privacy when you need it. But this is for all these values. If you are using a system that's that's not censorship resistant, when you're going to need, whether you want to change the system, it's important to have these values as a default. And this is what's the blockchain about.
Okay, cool. So I want to make sure we do finish on time or almost on time. I have a couple questions I saw in the chat. If anyone has any questions, you can put it in the chat, or if you want to ask yourself, you should be able to raise your hand and I can unmute you, I think. Let me know if that's not the case. Which one says, thanks Jordi for being here today. He has to go. Thanks Yuchan for joining. Okay, so one question is from Ayman. He's asking on the massive migrations that you mentioned earlier. How is that going? And is L2 interoperability something that other rollup projects are working maybe together with you or separately?
Yeah, it's a very early stage on that, because the rollups are just starting right now, and now we are like already talking about how these rollups interconnect in some way or the other. But and it is very early. It's very early stage. In order to first interconnect, you need to have different rollups and so on. But the idea is this. So imagine that, for example, you have a Hermez rollup and you have a Uniswap kind rollup. Okay, and there is a lot of traffic. There is a lot of transactions that goes from one to the other. The naive way to do that is you exit to layer one, you transfer to the other rollup, and then you deposit in the other rollup. This is very expensive and very inefficient. Okay, so massive migration, actually what it does, it just aggregates, aggregates for all the transfers that you want to do from this rollup to this other rollup. Okay, so they aggregate all this so they pack all these transactions. Okay, and then there is a single layer one transactions that actually move all the funds from here to here. And then here, we just again in layer two, they just unpack all this and put the balances in the right way. This can be done with the zero knowledge, so you can pack this and have the proof that it's packed, and then in the other, the unpacking is okay. You guarantee that follows the same packing than that, and this is what's about massive migrations. But it's about communication between rollups. And when I'm saying communication, it's not only about talking; it's also about transferring value, but done in an aggregated way, in a massive way. So instead of having thousands of transactions that go in the layer one, you compress all of them, or you are doing that in a single layer one transaction. And this is very important, because this is what will allow to have like an ecosystem of rollups. If you want an ecosystem of smart contracts, if you want, but it's an ecosystem of different applications. People can build their own application with their own rollup, and then they will interoperate, and they will not collapse. They will not fulfill the layer one, because these transactions can be aggregated on that. This is, I would say, this will be very important. It's not very important now,
most important,
because there is nothing with it, but it probably will be very important. But again, this is very early stage technology. We need to see how this all evolves. So I don't have a crystal ball, so it's difficult to see what will happen in 2 years or 3 years.
At this point, do you have any estimates of the gas saving, the cost saving?
It's
compared to
about
L1?
90%. It reduces one order of magnitude. So if a transaction costs you $2, maybe in a rollup it will cost 20 cents, more or less. That's depending on the quantity of the transactions, and there is a lot of variables in there. But a good order of, so it's one order of magnitude less. This is a normal. I would say this is a good.
And compared to the naive method of using L1?
Yeah, this is what I'm comparing. So if you are doing a transfer in layer one, if a transfer in layer one costs you $2, in doing the same in layer two would cost you around 20 cents.
Okay.
This is a starting point, but the rollups, the promise of the rollups is that this will go low because the capacity will increase.
Okay, cool. Then another question is from Sima Vohan. He's asking, and I'm paraphrasing here, please feel free to correct me. There's permissioned and permissionless blockchains. How is it different how are they different in terms of security?
Well, a permission blockchain, a permissioned blockchain, that means that there is somebody that has the key of the key of the box. Permissionless is anybody can use it and nobody can censorship that. So from the security perspective is what happened if this central point whatever, and it's like even the problem of centralization is not even about that this central actor becomes a bad actor. It's very imagine that this central actor is receive an attack of somebody else, or just receive some threats from a government or for somebody. No, it's like it's very vulnerable. It's a point of failure. Okay, so that's why it's important to have this decentralization point, and that if there is some operator, for example, that falls, there is another operator that can continue forging blocks. It's like miners in Bitcoin or in Ethereum. Okay, it's like if you censor a miner, it's worthless because there are many others.
And I think one good example can just be looking at Facebook's blockchain, where they have like some 100 of the biggest companies around the world, and they're still getting stopped by the regulators. So that's one sort of live example.
If you have the chance, it's like, well, yes, if you have the chance to interview somebody from Facebook, I have a question for them. I just want you to ask them. It's what happened if there is a hard fork in Libra. It's like I will get twice the euros that I have in there. That's a question for them. Just please ask if you have the chance to interview them.
Okay, I'll note it down to ask.
Thank you.
Yeah, okay, we're slightly past 9:30. If there's like one last question, feel free to ask. Otherwise, the only thing I'm gonna ask from you, Jordi, is how do people keep track or keep in touch with Hermez? What are some links that or channels that people can follow you?
Yeah, I don't know. I will send you the link. Let me put in the chat the link of the link. I don't know if Tony is there. I can put the link of the Hermez. We have a Telegram group. We have a Discord. We have a Twitter account right now that it's censored, by the way. I don't know what happened, but it's like censored. We're just fighting on that. That's crazy. That's a problem of censorship. It's crazy. We don't even know why. That's the worst thing. And but yeah, Tony is. I think Tony should be here, and he can put the links of the in the chat of the of the different ways to contact us.
Okay, and is there any difference between Telegram and Discord? Like, is one more for developers
Well,
versus community?
yeah, it's like I would say Telegram is more a generic channel where general news. So where if you just want to see what's going on, you can keep in there. But if you're a developer and you want to go deep in the code and you want to review circuits, if you want to run the trusted setup ceremony, if you want to ask more specific questions, if you want to meet some of the developers, then you can go to the Discord and to meet more the community in there. At some point, we probably will join them together, but we started in this way, so we are keeping both for these different purposes.
I think that's common for a lot of projects right now.
Yeah, and we are keeping the IDEN3 Telegram group for all the tooling part, for the Circom and for the Snark.js and all these more for devs in general.
Sorry, just a quick one. So is there can you describe the difference or the relation between IDEN3 and Hermez?
Well, mainly we are a project that we were building IDEN3 and we were building all these tooling systems, and mainly we got the same people. We are the same team that we, I'm not going to say froze because we are somebody continue working, but we just took the people, we built and we took the people from there, and we we are creating these areas. We will continue IDEN3. It's okay, it was split. It's the same team that instead of doing this right now, it's just focusing on doing this, but we will continue IDEN3.
So if Hermez is for scaling and L2, IDEN3 is for
identity. The self-sovereign identity. The idea of IDEN3 is to create a decentralized identity system. The story is for identity you need to scale, because identity you need to do claims, and so you need to scale. And you need also privacy. That's why we were building this tooling for zero knowledge. But with this tooling, we saw that we can build also a rollup. So in some way, let's use this tooling that we have, and instead of building identity, we build Hermez. But actually, we will build also identity, but we are focusing right now on Hermez. We took the developers, we took the people on the team, and are experts on this tool, and we put them to build this project. It's maybe the relationship.
Okay, cool. Yeah, so I think we're 5 minutes past time. We started 5 minutes late, so I guess we ended 5 minutes late. Thanks a lot, Jordi, for your time, for all your sharing. Yeah. Thanks, Tony, for joining as well. Yeah, so thanks everyone for joining. This is our February community meetup. We'll have another one first Thursday of the month in March. If you have any particular topics or particular guests you'd like us to invite, let me know. And yeah, I'm gonna find a link to our Telegram group just in case people here don't have access or are not in there yet, because I'll share the links that Tony and Jordi shared earlier, and some of the other links as well in the Telegram. So yeah, if you're not in there yet, join the group so you can see the links later. Otherwise, yeah, thanks again for your time.